Okay guys, so in this lesson we're gonna talk about more functions, more nested loops. So it's just an extension of function and nested loops. So all these are resources that have been provided before. So let's go through the quiz. Okay, so for the quiz we have this, and what it says is this is a for loop, right? And everything seems right. So what is the return value? What will it return? So if we see I is 0 already, so I would increment, right? So it will increment up to is less than 9. It will increment 0 to 9. So it's going to print out 0 to 9, but that's not the return. So after it has print out 9, what it will return is 10. Okay, so that's what it's going to return. Okay, so for this one, I is 48. So they are printing with character, which means they are going to be using ASCII um, numbers, ASCII representation in order to print it. So 48 is 0 in ASCII. So it's going to go from 0 to 9. Okay. So 48 is 0, 49 is 1 in ASCII, and so on like that. So for this one, we have what is the output of the following piece of code. We have this, and this is a while loop. And you can see it starts with -9. So if -9 is less than 0, right? So it will come here and then become +9. So that's how we get this 9. And then it will continue like that till it gets to 1. And then the 0 is not less than 0, so it will not print 0. Okay, so that's why this one is the answer. And then number 3, we have this one. This is a while loop as well. And then for this one, we'll have our 9 gets printed first, and then it will decrement by 1. Okay, so we'll, we'll have our 9. So this place will be -1, right? -1, 9, right? So we have our minus -1, and then probably +9 will give us 8, right? So 8, and then it will go on to till we get to 7, until we get to 1. Okay, so for this one, we have what is the output of the following. So this one is acting for the output as well. So this one we have same thing, right? So we're gonna have same thing, but this one the minus come after, so it will make us print this 0. Okay, and then we have this one. What is the output of the following code? So this one we are going to multiply it. So the first one is going to be 0. 0 times 2 is 0, and then the second one will be 1, right? It's going to go up to 9, 0 to 9. So 1 times 2, 2. 2 times 2, 4. 3 times 2, 6. 4 times 2, 8. Like that, up to 9 times 2, 18. Okay, and then we go to the next one. And on this one, we have our while loop as well. So it will go from 0 to 9 as well. So 0 divided by 2, 0. 1 divided by 2, 1. 2 divided by 2, 1. So we have 0, 1, 1. So this one automatically will be the answer. Okay, so this one, what is the output of the following piece of code? We have our while loop. Okay, and then this one will still go 0 to 9, and then 0 modulus 2 is going to be 0, and then 1 modulus 2 is going to be 1. 2 modulus 2 is going to be 0. So once you have 1, 0, 1, then 1, 0, 1, 0, and then this will be the answer. And then the last question, but not the least, what is the return value? What will it return? Okay, we've already said return is 98, so that will be 98. And then the next video we'll talk about the first task. See you. So okay guys, so we'll be doing the first task, which is task 0 is upper. Okay, so we should write a function that checks for upper case character. Okay, so this is the prototype, and then it should return 1 if the character, okay, if the value here is upper, or return 0 otherwise. So to do this, it's quite simple. So we're going to have our this is the main to test it. Okay, so I won't really be testing it because I don't want to waste our time, but you can test it and I'll show you how to test it. I'll probably just quickly explain how to test it. Okay, so major things I will need is this one and our main.h, right? So create this one, right? Go to this place. Before that, we have a new directory. So create a directory, and we'll put our readme inside. So you come here and then cd into ALX low level, right? And then ls. So we'll make our directory, right? and then we'll cd into that directory, right? So let me clear the screen and lists. So we have nothing. We first create our readme.md, right? So let me just put it like this. Tasks, right? So just make sure the readme is not empty. You can customize your readme if you want to put so many things inside. So far we have this one. So the next one I'll create is the file itself. So let me create this file, right? And then I'll press enter. So first I'll include my main.h. I'll be creating main.h later, and then my commenting, and then what's the name of this stuff? Is upper underscore is upper, right? So we'll declare this guy underscore is upper, and this one will print detect upper case alphabets, right? And then we have our at C, right? So what does C does? C is the input character. Did I just see int here? So it's an integer. Okay, anyway. Alright, so no problem. So and then it should return the return statement should be 1 for true and 0 for false. You can write anything here for now, and then okay, so let's copy the prototype. So you copy this prototype, copy it, and then you paste it here. Remove this guy, come down here, and then like this, right? We've had our ints here already. So we said um if what if C is upper, it should return 1. If our C is equal to is upper, so uppercase is if C is equal to A, right? And C is okay. I think this one will say if C is equal to A and C is um, less than equal to, so we'll say if C is greater than or equal to A. So we want it to read. So let's do greater than. So this one is saying that if C is greater than or equal to A, that is if it is A or anything above A, capital letter A, or C is less than equal to Z, capital letter. Okay, so we are saying that if C is greater than or equal to A, that if it is A or anything above A, or and if it is Z or anything below Z, then it should print what? It should return. So it should return. So we'll put our parentheses. Then return. It should return 1, right? Okay. Else, it should just return. Else, return 0, right? So I think this should work, right? Let me just check again. Otherwise return 0. Okay, so we'll put this in our main.h, and then we can you can test it. Okay, so escape wq, right? So we have it now. So we'll vi main.h. So our main.h now, the last time we didn't define some stuff to it, so right now just probably do it. And then, so in order for, this means if not defined. So if not defined, then we put the main.h there, main. So we do it this way, and underscore, right? And then define. So what this comment or this header does is that if we mistakenly put the prototype twice, it will make it work. Okay, so you just do if not defined, and then define. Okay, and then you put the name again, but separated with underscores, right? So, and then you can come down and then paste the prototype. Okay, I think we've copied it before, so let me just paste it. Good. And then we'll end it with an end if. Okay, so, and then so far we have our 1 2 3, right? So we have this 3 file, so we can actually we can test it. But before that, let me betty my 0 file, right? So it says space prohibited before the close parenthesis, so let's go there and change in line 12. So line 12, uh, space prohibited. Okay, yes, use it. I come back, go back. Yes. So let's check again. So Betty said we are good. So let us clear it ls again. So we are done with this. We're done with this. So we can git add and git push. But if you want to test it, you have to create a main.c file. Okay, and then the main.c file is here. So once you create this main.c file, 0 main.c, copy this guy, or let's just do it. Okay, so copy this one to test. Copy it, vi this, and then copy this guy. What I hate about this is it used to have so many petty problem. Okay, so then let me check for Betty. Set list. Okay, so it has so many Betty errors. So let me just quickly correct them. Set 1 2 3 4. 1 2 1 2 3 4 1 2 1 2 3 4 1 2 Okay, I think we are good. So we have that. Okay, ls. Okay, so our main dot, so we have 0 main dot c. So we execute our this 0 is upper. Okay, is upper. So to execute it, you just copy this guy in gcc. Okay, so I'm just trying to test it, and then okay, and then yes, if we release it, you have 0 is upper. Then I can try to execute it, right? 0 is upper. So what should it give us? A1, A0. So let's see if you are right. So A1, A0, it means we are right. Okay. So I want to, let me clear my screen. Okay. So I want to git add everything. This one, this one, this one. I don't want to git add this guys. Okay. So I could just say, I could do what I could vi dot git ignore file. So git ignore contains files that git should ignore. So I could add my 0 main.c and my 0 is upper, right? So I'll just do like this, and then I'll add my 0 dash main dot c, and where's the other one? And sorry, 0 is upper only without the dot c. Yes, escape wq. So if I list it, yes. So I've hidden it. In order to see that one, I'll do ls dash a, right? And then I'll see my dot git ignore. So I've put it that git should ignore these files, those two files. Then I can just clear it, and then git add, git commit, and then say check for upper case alphabet, and then git push. Okay, so so let's check our code and see. So it says we are good. So that's that, and then we'll go to the next question. So see you in the next question. Okay, guys. So in this lesson, we have to do number one, which is one is digits. Okay. So you write a function that checks a digit 0 through 9. Okay, and then this is the prototype. You should return 1 if c is a digit. So we want to know if what the input is a digit and 0 otherwise. Okay, so let me just copy it, and as you can see here, 0 is passed into the function, which means it's a digit, so it returns 1, and a is passed and it returns 0. So let's copy 1 is digit. Okay, so let me reload this my terminal. Right. Okay, so ls, okay, cd into lx low level 1, ls, and cd to 0x04. Okay, so let's clear this. Okay, so we vi name, right, then hashtag include, then we include our main.h. Sorry, and then we add our comments in, and I think it is underscore is digit, right? I'm not sure. Check again. So so this one is to check if parameter is a digit or character. Okay, then we have, I think at C, so will be the parameter, right? And then we should return 1 if it's a number, and 0 otherwise. Then we have our prototype. Let me just copy it. So underscore digit is correct. Copy this one, this guy, and then this guy. Right. Tab. So what we're going to do is we'll say put our if statement directly and say if, right, if what it says return one if c is a digit. So if c, right, is a digit, you first say is a, right. So a digit, um if you are printing, you could use ASCII number to represent it, and then ASCII value for digit is 48. This one is for a, is for numbers, right. So if c is equal to a, so we want to say is greater than or equal to a, because we want it to say from a above, right, from I said a, from 0 above, right. So 48 is the representation of 0, and so if it is 0 and if c is less than or equal to 9, and then 9 is 57. Okay, so yeah, so we should be good like this. So this one, it should return 1, okay, or else should it should return 0. Why is this thing frozen again? Else it should return 0. Okay, and let's add ls. So let's add 1 is digits, right. So we'll add that prototype to the main.h. Okay, this thing is freezing. Okay, right, and then that will be all for now, and then we can test it. We have to have this one main.c. Okay, so this one main.c, I don't want it to be pushed, so let me just put it in dot git ignore. So vi dot git ignore, right, and I'll put I. So this one is 1p. I made mistake the other time. And okay, yes, and then vi. So let's test it. In order to test it, we'll have this one, right. Okay, let's check for space. Why is this thing freezing? So we have so many white space, so let me just delete them. Oh, sorry. think we're good. Okay, we don't even need to bet it since we are not even pushing it. So the next thing is to let's check our code, which is one is digit and see. Betty one is digit. One is digit. Okay, so we are good. So let's compile and see. Okay. I think it compiled. So one let's do ls. And so let's execute one is digit. Right. We have 10, which is the output, which is correct. So I don't want to push this one is digit. Okay, so let me copy this guy and paste it to my executive now. So I can git add in peace, git commit, and then my commit message is find out if parameter is the number or an alpha get. Right. And then we push. So let's check it now. Let's see. So based on so we are correct, and that'll be all for now. Okay guys, so in this lesson, this number 2, we say collaboration is multiplication. Write a function that multiplies two integers. Okay, so this one is quite simple. We've done this kind of function so many times. So the first thing I will do is vi. What's the function name? So it's a multiply. They passed in these numbers into it, and then it gave these answers. Right. So 2 dash mul dot c vi 2 dash mul dot c. Then we will include our header file, which is main dot h to the function, and then we'll have our what's it called, description kind of, and then it is I think mul of multiply two integers, right? So I think we're going to have a and b, so let me just reduce. Why is this thing hanging? At a first integer, we have at no. Why is this thing hanging? At b second integer. So it's not putting star. Let's put it manually. You should return. You should return multiplication. I don't know why it's not putting this. I hope it works. So it's, I mean, there's no space here. Let me put it myself. I'm not sure if I'm doing it. So, let's see. Okay, so if the compiler complain or get a complaint, you know. So I've copied the prototype before. I just try to paste it and it's not pasting. So let me recopy it. Okay, so we go up, we copy. Okay, it's even my network is slow. It has pasted it. Okay, and then so we should have, best way to do is we can just say you should return and then a times b. It's as simple as this. We could do it this way. Another way of doing this um, is to set a value. Okay, and then so you can say multiplication is what, equals to a times b, and then you say return multiplication. Okay, so you can do it this way or you can do it this way. Okay, so so let's, or you say int multiplication rather. Okay, so you int, yes, something like this. Okay, yes, so you can do it this way, you can do it this way. So let's claim one. Let's just claim the one below. Okay, so these are the two ways to do it. Okay, so yes. Okay, so let's, what is it, 2, so let's get it at 2. Okay, that is where we are good. So we want to vi the main.h, right, and put that prototype. Okay, that's good. We are done like this, but if we want to test, we could test it. And to test it, we just come here, we create our main.c, two main.c. Okay. Since we are not pushing this guy, we don't need to make sure it's better standard. Okay, we don't need to make sure since we are not pushing. Okay, and then we have our compiler. So it worked. So let's list it. We have 2 mul. So let us run it. So we should have that number. Okay, so I will go to my tool, git ignore. That git should ignore this file and this file, these two files. Okay, so I'll just say 2 dash 2 main dot c and 2 mul, right, 2 main dot c, 2 mul. Okay, so let's git add it, git commit, So multiply two integers, and then I'll give push. Okay, so let's check our code. And that'll be all for now. Bye. Okay guys, so in this lesson we're going to talk about the numbers speak for them, number task 4, number 3. And it says write a function that prints 0 to 9 followed by a new line. So we should write a function that will print this 0 to 9. You should print a number 0 to 9 and then a new line, and we have to use this underscore putchar. Remember that if we are to use the underscore putchar, it means that we have to have declared putchar in our stuff. Okay, so basically what I'll do is I'll copy. Let's first create this putchar, right? Okay, so underscore putchar. So you go to your terminal, and then we have the putchar in, I think, let me clear my screen. Let me see the outside. So ls, sorry, ls. So we have the putchar in this 0x02. Okay, so I can just copy it and paste it in 0x04. So I'll seed into 0x02 ls, and as you can see we have the putchar here, underscore putchar. So I'll copy underscore putchar, okay, and paste it in 0x04 dash more underscore functions underscore nested underscore loops. Okay, so let's see. So let's see the outside and go back to cd0x04, and let's see if it is there. It did come here? No, it didn't come here. It went to home, I guess. Okay, so let me go back there. And let me clear. I'm very sure that that one that we copied just now went to home. So let me see the into x02 back, and I'll find any other way to do it. Ls, right? So we want to copy that guy. Where is it? Okay, yeah. I want to copy this guy. So this guy is in the parent directory, right? So I'll just put dot here, dot, enter. Okay, so let's go back to where we are coming from. See the outside, see the 0x04. Okay, ls. So we have our putchar here. And putchar, if we vi putchar, okay, putchar, this is the prototype, so I'll put it in the header file. Okay, and this one is just saying that it should return. This one means return to standard output. Okay, and then this one means it's going to receive one character. As you can see, this one is number of character is going to receive, and then ampersand c. This one is like a pointer to c, meaning that it's receiving a character. Okay, so so let's quit it. He brought list of command that I use. Okay, so vi vi main.h. Okay, and then we'll add that to it so it can work. Right, and then don't forget semicolon. Right, and then ls. So we clear our screen list. So we'll go back here. So we've declared this one to be working fine. So we need to print out. So copy this 3print.c, copy it, and then vi it, right, and then we go to insert mode, and then we include our header file. And then we do this, and then the name is print numbers, right? Print underscore numbers. And we have to print numbers range 0 to 9. And it's going to receive, does it have any parameter? No. So does it have return? Yes. So it's going to return, it's 0, I guess, or no return. Okay, this one, since it is the void, it is void, it will have no return, so we don't need to specify the return. Okay, I think it is void. So have I copied this guy? No, thought I've copied the prototype. Okay, so go here, copy the prototype. I'm sorry, prototype is up, void print number void. So it has no return value. Yes, so I will delete this guy. Okay. Okay, so the next thing is, let me declare an integer. Okay, so I'll say this one is the print, right? Okay, so we are using this stuff, so I'll use my for loop to loop through. I can use while loop as well, right? So we are following through, be able to use the while loop as we've used for now. So pr equals to what is 0? 0 is 48, so we can use 48 since we are using int. So, and then we'll say pr is less than, what is 10? Because we are printing up to, we can say it is less than or equal to 9 is 57, right? Then we'll say pr plus plus, right? And then here we'll underscore put jar, and then we'll print pr, right? And then print a new line. Sorry, just want this, and then I think we're done. So let me see if we have space. We don't have. Okay, so let me bet it. So Betty said we are good, so we can just write our main. So 3 main.c, and then this the stuff that will pass into it. Copy. We are 3 main.c, and then I'll paste this guy into it. Okay. Yes. So we have all we need. So let me compile and see. So we are supposed to have 0 to 9 printed, right? So enter. Okay, we have one error. Implicit print numbers, number 10, print numbers. Let's see, print numbers. There's 3 print numbers. Okay, I think in the compilation, 3 print number. Is there print number in the compilation? Okay, let me just see. um 19. Why is it not bringing anything out? Why is this guy not bringing anything out again? We don't have anything that is complicated here. I don't know why this guy is not compiling, but let me just git add. Okay, I didn't put my prototype in main.h for 3 print number. Okay, so that's why main.h. Okay, we are main.h, and then this guy. So this is why it didn't work. So sorry. I was looking at that grammar. I was confused at a second. Right. So let's recompile. So GCC was right. So if we list it, we'll have 3 print numbers. So let us execute it. So we have 0 to 9, right? And then it worked. So we don't want to print out, we don't want to push 3 print number, we don't want to put 3 main.c, right? These two. So I'll add to my git ignore. So 3 print number and 3 main.c. Let me just copy this one. Okay, copy, and then vi. So this 3 main.c. Then I'll git add, git commit. Hey, I said I wanted to press 0 to 9. I said 0 to 9. Anyway, I'm very sure in another language you means to. Okay, let's see. So let's check our code and start. So it worked, and we go to the next task. Okay guys, so in this task we want to do number 4, which it says we should write a function that prints 0 to 9 like the previous one, but the difference is we should not print 2 and 4. Okay, and we should only use push twice. So we're going to use a loop and then print this. So for this one, what we're going to do is let's copy this. Let me copy this one because sometimes I forget and put it in the header file, but we'll be needing it, so let me just do that last. So let me first do this one and then write the code inside. Right, so go to our terminal, right, and then vi this number 4, right. Then we include our main.h, and then we write our function. What's our function name again? I think it is file page up print most numbers. Okay, so I think it is print underscore most numbers, right, and then dash. So it print 0 to 9 x except let's say 2 and 4. Okay, so um, does it have any return type? No, it is void, so we can end it like this. So we paste this one, delete this one, enter, delete. So we'll do like what we did before, and then we'll just put our if statements inside. So we'll have our int that will hold the numbers, right? I think we use PR the other time, and then what else? Then we'll have our for loop. Okay, so let me just print out our new line. Since it's not going to have a return type, which okay, yes. So for this one, we'll set it so we can say as far as num is equals to double equal to, right? Or we are assigning. So let's do this. Not equal to, we are assigning a number to it. So if we assign 0 to it, it means we have to convert it when we are printing it out, or we convert it here first. Okay, so let's first assign 0, then we'll convert it down. Okay, so n is 0, and then num is less than 10. You can say less than 10 or less than equal to 9. Let's just use less than equal to 9 as we are used to that one. Okay, and then we say num plus plus y. Okay, so you can now say, before you print it, go through this if statements. So we have our if statement, and then right, and then okay, so let me just, at the end we'll be printing out num, right? And then we'll convert it, so we'll add it by 0 to convert it by 0, right? Okay, so before we print it out, we'll then say if number is not equal to 2 and number is not equal to 4, then you should print number. Okay, so you should print num. Another way to do this is print, yes, we should just print number. I think this one should work. So let's try it out. If it doesn't work, then we'll say print num, then we'll do remainder of 10, that's 10, num modulus 10 in brackets, and then that will still give us remainder. So let's just see. Okay, so add the prototype. So add the prototype, right? Okay, so let's do the main and test it. For main.h. This one is quite short, very nice. Main.cl. So let's betty our, what's this, 4 print most numbers. So betty is okay, let me clean it. Okay, and then let's compile and see. So if it doesn't work, we'll do it the other way, right? So copy this guy. So now as a executed, and then let's see. So it printed 0, 1, 3, 5, 6, 7, 8, 9. So it printed 0, 1, 2. So I think 0, 1, 3, 4. Yeah. So it worked. So we just clear our screen, ls, and then we want Git to ignore this guy and form index, right? So I don't want to push these guys, so I'll just copy and then dot git, sorry, vi dot git ignore, right? And then and for main dot c, right? And then I'll git add with commits print 0 to 9 without 2 and 4, and then git push. Okay, so let's check our code and see if it worked. So it worked, and then yeah, so that's that. So see you in the next video. Okay guys, so on this lesson we're going to talk about task 6, which is number 5. Numbers constitute the only universal language. Okay, so we have to print 10 times the number. So we have to print 0 to 14 10 times, okay, followed by a new line. So we can only use picture 3 times, and then this is the prototype. Okay, so basically when they execute it, you see 0 to 14. And to print double number using picture, we have to use a statement that says the number divided by 10, divided by 10 will give us the first number since it's 2 digits, and then modulus 10 will give us the second number. For example, 14 divided by 10, okay, it will give us 1, right? Remember, we don't know, okay, and then 14 modulus 10, right, will give us 4, because 1 will go and then 4 will remain, so that will give us. So we use this kind of statement to try and get what our output will be. Okay, so what we should do is I've copied this 5 more, right? Okay, and then we'll go here and mix it into ALX low level, set into 0, 4. Okay, so we have it here, and then let's VR into it. Okay, so we have our, let's include our main.h, right? Alright, that part, and then we have our, what's the prototype called? I think more numbers, more underscore numbers. So this one will print 0 to 14 10 times, right? And then does it have an int? No, and it doesn't have a return statement, so we'll just leave that at that. And then we'll have our prototype. Oh, sorry, let me undo that. I just undid it now. Hey, it undid everything now. Okay, redo, what's that redo again? Let me see. Okay, okay, it's already in the HST. I can't remember command for redo. So let me, should I check, or let's check so we learn together. How do I redo changes on VR? I can't remember. Control R. Are you sure? Let's try it anyway. Control, I think capital letter R. This one reload the page. Oh. See what these people has turned us to, because I know it can never be that. But it has reload, so it's impossible for us to get it. So let's go back there and cd dot sorry cd oxo alx 11 cd oxo ls. So we'll do ls dash a because we have a crashed version of that guy. Where is this? Look at this .5. It's going to give us issue. So let's remove it, or let's vi into it. Vi is 2.5. Oh, it's rubbish. So let's quit it. Let's remove it. It's going to give us issue. Okay, so let's vi.5. Okay, let's just redo it. Okay, include USB fast main.h, and then we'll have our prototype to be more underscore numbers. Right, this thing is hanging. Print 0 to 14 times. It has no return value. Okay, so we copy the prototype. Okay, right, we do this and then move this guy. So it will have no return value, and then let's go up. So the next thing we want to do is we should have an int to store in some stuff. Okay, so we have to, since we are going to go to true loop, so int I and int j, right? So the first for loop will help us do what printing of this 0 to 14 10 times. Okay, so we'll do int, oh sorry, for, right, we'll do for, and then enter this, right? So this one wants to go 10 times, so we'll say for I equals to 1, for I is equals to 0, I is less than equal to 9, so that one will go 10 times, and then I plus plus. Okay, so inside this space then we'll have another for loop, right? So you can have another while loop instead of the for loop though. Okay, so this thing is on there. Okay, so before that then we'll have the for loop to print the numbers. I will say j equals to 0. So since we are using 0, it means we'll convert the put j is less than equal to 14. No, less than equal to 14, yes, because it's going to print from 0 to 14, and j plus plus. I was thinking 13 but we are printing 0 as well, so yes. So what we want to do normally is just say underscore put jar, right? Should print g. right? You should print J, and then we want to convert it, right? Well, we can also say J, you should print J modulus 10. Okay, so J modulus 10 will give us the last digit. So 1 divided by 10 is still 1, up to 9. When it gets to 10, it's going to give us 0 back. Okay, so in order to do that, then we'll come here and declare an if statement. Okay, so we'll do if, and then like this. So we'll say if J, once J is less than or equal to um, no, greater than or equal to, should be greater than or equal to 10. Okay, so if J becomes greater than or equal to 10, you should first do this. You should print the first number first before it comes to print the last number. Okay, so it's going to print 1 before it starts printing 0 and 1 and 2 and 3 and 4. Okay, so it will keep printing this one. So we can even say you should print 1 self if, but anyway, we'll just say print, right? What should you print? Okay, you should print okay, convert to 0, convert to this, right? So you should print J divided by 10. Okay, so we can just put these guys into brackets, and then this one too, and then put a new line after the first volume, right after the first. Let's go right, and I think we should be good at this. Okay, so let me clear my screen, ls, and then 5 more dots, then we'll see dot slash, sorry, Betty, 5 more dots. So multiple instruction line what, line 8. So let's vr 9 8. Where's the multiple instruction? Okay, sorry, I'm supposed to put comma there, not semicolon. It's correct. I've corrected it now. Yeah, now what's going on? Am I frozen? Okay, please don't freeze up. Let's Betty again. So Betty said we are right. So let's veer into the main.h and then add that prototype. Right. Okay. So the next thing we want to do is we want to create our 5 main.c to run our program and see. So right. So 5 main.c. We've done that, I guess. So yeah. So let's compile and see if we have our output. So we compiled, we released it, then we have 5, let's execute it, 5 more. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are correct. Okay. So this guy, I don't want it to push it. This guy and 5 main.c. So I'll veer into my .qtick now, and then I'll add it to it. Okay, git add, git commit, print 0 to 10 times, and then git push. So let me go and check and see if it worked. Hopefully, because what's going on? Oh, it's checker time. So it's checker time. It's almost time. No, it's not checker time. Okay, it's almost checker time. So checker is having issue right now. So definitely this should work. If it doesn't work, I'm going to amend it, okay, before I upload the video. So see you. Okay guys, so in this lesson number 6, task 7, it said write a function that draws a straight line in the terminal. So we know this underscore will draw straight lines, right? So we just have to loop through and do this. But it now says that where n is the number of times the character will be printed, okay, the line should end with a new line, right? And if n is 0 or less, the function should only print new line, okay? So we are going to say that n has to be greater than 0, okay, for that to happen, okay? So basically, let's just get the file name, then we'll copy this guy, then we'll go here. Let me clear my then we'll go this print line, let's see, right? Enter. Okay, then we'll include main.h. Then so what is the name of that stuff? I think print line. So print underscore print line. Okay, to draw a straight line and terminal. Okay, sorry, my print is not correct. Let me try and correct it. Why is this thing hanging? Okay, do we have any input? I think n, right? So at n input, should we have a return type? Why is it not? It's not auto given me. So let's leave that like that. And then I think it doesn't have what's it called? Okay, you can have that. So just copy the prototype. Prototype copied. Okay, so because we have to use a particular just one loop, right? So let me just declare things and let's use a for loop, right? As for is easy as fuck. Okay, So this one now we say I I is equals to 0. Initialize that, and then I is greater than or equal to, or I is less than n rather. Okay, I is less than n because 0 is less than n, right? And then we'll say I plus plus. Okay, so then normally, and then we'll have our if statement. So if so let me just format this guy well. Okay, so if yes, right, so if our n is, so I is less than whatever is here. Okay, if our n is greater than 0, okay, that is when you should print a new line. Underscore put char. So new line will be this underscore this, right? And then if not, you should underscore put char. New line. Okay, so what we're doing is we need to print, what is it, the new line only if with the value of n, right? So if n is, for example, if n is 7, 7 is greater than 0, right? Then it will print n, right? If n is greater than 0, that's when you should print this new line. And then you say this place is 0 as long as 0 is less than n. Okay, so as long as 0 is less than n, you should print, and then continuously like that. So let me see if we are missing anything. So yeah, okay, so it will start from 0. So for this one now, if you have 2, so if that I put 1 here, I would have said less than or equal to n. Okay, so this place is 0, and it means that 0, 2 is a number, right? So it will start from 1. So if this place is 2, 0 is less than 2, so it will print, it will first go, it will print this new line, right? It will come again, it will become 1, it will print it, but 2 is not less than 2, so it will stop there. So it will print it twice. Okay, so that's just the basic idea. I don't know if you can see my cursor because on terminal it doesn't show. So anyway, I hope you understand. Okay, so ls, and let's Betty the file. Okay, so Betty say we are good. So let us be our main.h and put the prototype in it. Right. Okay, so let us be our tester. Sys main.c. Copy. Here sys main.c, right? And then paste this guy. Save it. Okay. So let us compile and see if you get an error, because checker is having issue right now, so or it's not working right now till close to deadline. Okay, so let me clear. So it means 6 lines, right? So we have this 1 2 space space. Okay, so and that is what we have, 1 2 space space. Okay, so what else? I think we're done. So I don't want 6 line and 6 main dot c, so I want Git to ignore it. And 6 main dot c, right? And then Git add Git commit print lines to terminal, and then Git push. As my push pressed, good. Okay, so let's check. I'm not sure if the last one has even checked. Still checking. So we're going to check this one, and once we check, if we have any error, I'm going to add it to the video. So if you're not seeing any error now, correct. If you're not seeing any correction now, it means that it has checked. So yeah, see you guys. Okay guys, so in this task we have to do this task 8, which is number 7. Write a function that draws the diagonal line on the terminal. And then here's the prototype. We said we should only use put char, and then n is the number of times this dash should be printed. The diagonal line should end with a new line, and if n is 0 or less, the function should print only a new line. You can see anytime is almost like the one we did before, but this one, every time a new line is printed, there's a space printed. Okay, so each time one is printed, spaces are printed based on the numbers. So the first thing we'll do is we'll copy this guy. Okay, and we'll save here this. Then we include our header file, right? We include our header file, and then after including our header file, we'll have our description. I think it is print diagonal. Right? So print diagonal lines, and then we have an input n, number of inputs. Okay, we can end it here, and then let's copy our prototype. So our prototype is, I think we'll put this one in our header file and we'll put it there. I think I've already put it in my header file. So okay, so copy, you exit, and then we'll have this. Okay, so the first thing I want to do is initiate my int I and j. Okay, so the next thing I'm going to do is create a for loop, right? And then my for loop will have this. So for the for loop, the next thing I'm going to do is create, as long as let me see, I equals to 0. You see, so as long as our I, which is 0, is less than our n, I plus plus. Okay, so this one is saying that as long as our n is greater than 0, okay, it's the same thing, because this one is 0. 0 is less than n, right? As long as 0 is less than n, then you should what? You should print, then print what? print a print diagonal line and print a new line, right? Print a new line. Where is new line? Bam, 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 bam. Okay, so that's for when it is greater than 0, right? So we have, so this loop will work. So what if our n is 0 or is less than 0? Okay, so we'll come here and we can put if our n is less than or equal to 0, then we should just print new line, right? So just print new line, right? Okay, so we have one more thing to do, because we know that every time this thing is printing, okay, it is printing a new line, so we want to add that to it. So we'll come here and add an if statement. I hope this thing has not hanged. If it hanged anyway, I'll just copy it and then we'll redo it because we've done this thing like 10 times now. It keeps on hanging. Okay, so come down and say if our n is greater than, right, if our n is greater than 1, so once our n is greater than 1, if it is 1, it's going to just print 1 and then print new line. But if it is greater than 1, let's say it is 2, it's going to print it's going to put space. Okay, so it's going to put input space after that one, print it, input space, print input space. So that space that I want to do, if it is like this, then we'll have a for loop to do the math for us, right? To do the magic. So we'll use this j. So we'll say as long as j is equal to 0, as long as j, so it means 0, right? J is 0 now. J is less than I, right? Which is true. Okay, this is our I now. As long if our I is 2 from here, okay, so our j and then I is, so it means that if it is 1 here, this one will not execute, it will come there. But once it is 2, it will come here. Okay, so now our j is 0, our j is less than this thing, right? So if this one is 2, for example, it means this loop will appear 2 times, right? Okay, so j is greater than I, and then we'll put this, and then we'll say j plus plus. Okay, so what will j do for us? This one will just help us print in the line. So let me just format it like this, and then put char, and then this, right, print new line. Okay, so this is what we do. So we print new line. Okay, this one is like backslash is escape, so by using 2 it means that it's going to print 1. So let me see what else are we missing. Yes, so I think this should work. So what we are saying is once it's greater than 1, it will come here. This one is 2, right? It means once it's greater than 1, it will come here. It will print a new line. It's not new line, space rather. It's supposed to print space. It will print space, right? And then come and then 2 space, right? And then print this new backslash. Right, so the first one it will just print this one. For the second one it will print 2 space and then print this one, and then go to the loop again. For the third one it will print 3 space and then come here. For the fourth one it will go here 4 times, right? So I think that's it. So excuse the new queue. Okay, so we'll have to create our 7 main. I've already put vi main dot h, so I've already put this one here. Okay, so you have to put that one there too. And then so vi 7 main.c, so copy our 7 main.c, which is here. I'm supposed to betty our stuff, right? So let me betty our 7 print diagonal. So Betty say we are good, right? So let me clear it and then let's compare. Compilation worked, so let's execute. See, so it printed as we wanted it to print. As you can see the output here, right? So it worked. So we have to git add and git push. But before that, I don't want to push some files. I don't want to push 7 diagonal. I don't want to push 7. So I'll add it to my git now, right? So let me just copy this guy. 7 diagonals. Vi dot git ignore 7 diagonal and 7. Let's see. What's happening? I thought I already exit and quit. What's going on? I already exited it now. Maybe it didn't exit. Okay, good. So let's git add, git commit, print now now, and then git push. Okay, clear. So let's check. So let's see if this one works. Okay, so it worked, and we'll go to the next one. So see you guys. Okay guys, so in this, let's say we are to write a function that prints a square followed by a new line. Okay, so it's going to print a square, and you know square have the same size, right? So we are such okay, so this is the prototype. We are to use butcher where size is the size of the square, I mean this size, right? And then size, if size is 0 or less, the function should only print a new line, but and then use the character hashtag to print square. As you can see, this one is 2, it's going to print 2 here, 2 here, so 2 2, 2 by 2 10, 10 will be 10 by 10, and then 0 0 will just be new lines, which is new line, and then back to this place. Okay, so let's create the file name, right? So come down here, copy the file name, copy, then I'll vi the file, and then include my main.h, and then my prototype, page up, page up. So it's going to return nothing, but it's going to have a parameter of in size. So let me paste this guy, right? Print square with hashtag. So I want to remove this void. Okay, so we have a parameter of size, number of square, right? And then it returns void. Then I'll paste this guy. I've pasted it now. Okay, So we're back here, and then yes, so we'll declare two int as well, int I comma j, right, and then there's going to be space. So the first one is if the size is 0, and we have if the size is greater than 0. Okay, so if size, sorry, if, why is this thing hanging? Please be fast, bro. This thing is hanging. Man, move, 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 move. Okay. Okay. If size, which is this, is greater than 0. So we'll do if size is less than or equal to 0 as well. Okay. So if size is greater than 0, then, oh sorry, then undergo this loop, then for loop, right? For loop, and the for loop will have this syntax, right? So let me just put this guy with tab so it will be better to view, right? Okay, so we'll have for loop, and this one will print the hashtag. Okay, so we'll say for loop, and then for I equal to 0. Okay, and then I is less than size. So what we are telling it here is that if this one is 0, so size has to be a number that is greater than 0 for this loop to work. Okay, so it means 0 is less than size, that is 0 is less than 1, 0 is less than 2, and you can do size is greater than I as well. Okay, okay, so and then I plus plus. Okay, so as far as this thing is there, so we'll just say so this one will print the number of, if this one is 2 for example. Okay, so it means 0 is less than this, so it means this one will continue 2 times. Abi? Okay, so where is it? Okay, so if this one is 1, it means this one will continue 2 times. Okay, so the next thing is we have another for loop inside. So it's like a for loop inside another for loop, right? And then okay, so we'll say j equals to 0. J is now, j2 is less than size, and we have j plus plus. So these guys, they want to do the same thing, and then okay, so and then we have inner loop, right? So this one will print put char underscore put char, and they said our box should be hashtag, right? So we put hash here. So that's what our square will be. So we'll come here, this outside the loop, and then we'll say else, right? So else, it means that size is less than 0, right? So I can just else, and then so else size is less than 0, and then if it is less than 0, it should just print underscore put char, it should just print a new line, right? Yes. So what else? I think so. Basically, what we are saying is that if it is greater than 0, it should going to do this. If it is less than 0 or 0, okay, it should print new line. So if it is greater than 0, what should it do? So if you look at, it's going to print this hashtag, right? But before it prints, is greater than 0, it will come here, and then it will come into the first for loop, and then I don't know if you can see my cursor though. I'm trying to move it, but I don't know if you guys can see it. So okay, let me highlight it. So what happened is the for loop will come into here, okay, and then our I is going to be 0. Okay, we said I is 0. So 0 is less than, let's say our size is 1 now. Okay, 0 is less, as far as less than 1. Okay, so 0 is less than 1, right? True. So it's, and then 1 I plus plus. So what this one will do is it will execute whatever is inside this place, right? It will execute it. If it is 1, it will execute it once, right? Because 0 will only be less than 1 once. Okay, so once that happens, it will enter here, and in trying to print this thing, so it will enter here first. So 0 is less than 1, so it will enter here, and then we go through another loop, and then 0 is less than 1 2, right? So it will then print this thing. It will then go back here, increase it, and then for 1 it will only print it once. If it is 2, right, it will come here. Okay, so if our size is 2, for example, 2 will be here, right? So 0 is less than 2, right? Yes, it will come here. This one too, 0 is less than 2, right? It will print this guy, hash. So it will come here again. 0, come to this place, and this one will increase it. 1 is less than 2, right? It will print the second hash, right? So it will come here again. 2 is less than 2, no. Then it will leave this guy. It will go to the beginning again, and then it will come back and print like that. So basically that's what it will do. It will come here and then print this guy, finish the loop, and then continue again. Wait, I think we should have a new line as well, right? No, yes, we should have a new line, so that when this guy is done, it's going to print new line and then add it up. So the new line should be that is, it should be after this, it should be after this guy. It should be after this guy. Please don't hang now. I don't have time. Don't hang. This thing is hanging, so it's wasting my time. Okay. Underscore put jar. So let's print a new line here. Papa backslash n. Okay. I think we should be done like this. Okay. So let's bet it. So we said we are good. Then let's vi our main.h and add that part with the prototype. Okay. And then what else? We'll copy our main.c. 8 main.c. Okay, so what else will compile? Okay, so it has compiled. So let's try and execute it. So this is 8 squares slash 8 squares. So we have what it is supposed to have. So I think that's it. So the next thing is I don't want to push this 8 square and 8 main.c. Okay, so I will add it to my git ignore. Okay, copy. Here I git ignore and 8 main.c. Okay, so let's clear git add, git commit, and this one is to print squares. Hey, okay. Let me push. So let's check if we are right. So we are right, and then we'll go to the next question. See you guys. Okay, so we'll be doing the 10 task, which is number 9. So it says the FizzBuzz test is an interview question designed to help filter out 99.5% of programming job candidates who can't seem to program their way out of a wet paper bag. Okay, so write a program that prints the number from 1 to 100. Okay, and then followed by a new line. Simple. But for the multiple of 3, so those that can go in 3, right, where 3 would, when you divide it by 3, it will remain 0. Print fizz instead of the number. And for multiple of I, print buzz. And for multiple of both, right, you should print FizzBuzz. Okay, and then each number or word should be separated by a space, and we are allowed to use standard library. So this one will not have prototype, and then we'll just use our standard library in order to print it. As you can see, 1 2 3 fizz, 4 5 buzz, 5 buzz, 6 3 can go in 6 fizz, 7 8 9 3 can go, 10 5 can go, and then 89 90 90 5 can go, 3 can go. That's why we print FizzBuzz. Okay, and so on like that. So I just create the file name. So this one will not need main.h. Just copy, go to my terminal, good, clear, ls. Okay, so I'll vid name. Okay, so vi has opened, and then I will include my stdio.h. Okay, and then I'll put my main to print 1 to 100, and let me just say FizzBuzz because I don't want to be explaining what I don't want to explain. Multiple of 3 and 5 FizzBuzz. Okay, let's just leave that one for now because it doesn't really matter. Okay, and then do we have a parameter? No. Return, we should return 0. 0 is okay like this. Okay, so we have our, so you should return 0, so that will be an int, right? And then we have our main, and then we'll pass it our void, right? And we'll do like this. Okay, all right. So the first thing we want to do is we'll use our for loop, and then we'll have an int I, right? Okay, I'll try 2 things and let's see which one works. So we'll try our for loop, and then, oh, my light is gone. Okay, my light is gone. So for this one, I will say for I equals to 1 now, right? And then I is less than or equal to 100. So this one will print 1 to 100, right? I plus plus. Okay, okay, so that's all. So you can now put if statements there. If, and then this, right? So if our I is can divide 3 and it will equal to 0, and let's start from the FizzBuzz. Our I can divide 5 and it will equal to 0, then, so this one, let me just put it in a bracket on its own. right? And then this one, a bracket on its own, right? Okay. Then it should print. So you can use printf now. FizzBuzz, right? It should print FizzBuzz and put a space, right? So that's that. And then we have our else if. So else if our I is just divisor of 3 alone, our I will divide 3 and will equals to 0 alone. It should print printf or let's do it accordingly, right? Let's just leave it. Let me just leave it. Printf okay, colon here. Alright. You should print for 3, you should print fizz, right? Fizz and then a space, right? And then else if our I is a divisor of 5 and it will give us 5 inside 0, then it should print buzz and a space, right? And then else you should just print the number. Else just print percent d space, right? And I, right? So after that, print a new line. So this one might work, or if this one doesn't work, then there's one more method. Okay, so just add one thing and then let's return 0 as usual. So this one you should print a new line. So we'll add our new line to it, /n. Okay, so I think we're done for now. So let's escape and WQ. So what else? We don't need to, we can just compile, right? We don't need to add any main.h or anything. So before that, I will Betty it to see if we don't have any Betty error. So Betty, Betty say we are good, then let's compile. Compilation said we have one error at number 33. Control reaches end of non-void function. Line 33, let's see. Do we have up to line 33? What is it saying? Let me zoom out. This thing is not zooming out. I don't know why. This one. Okay. Yes, now it's correct. So what's now happening? Control reaches end of non-void function. In main function, in function main. Control reaches end of non-void. function. Let me see. Let me see. I'm not sure I have any error for now. Okay. Windows like this. Let me see. Let's recompile. 34. Control reaches end of known void function. Okay, let me just GCC the file. GCC now. So we have a.out ls. We have a.out. Let me run it. Okay, this one only printed 1, so there's an issue. There's an issue with it. Okay, vi. So let me do the second method. 7 minutes. No, 9 minutes. Right. So the second method I want to use is just simple. So we'll use this one to print 1 to 99. In order to print 1 to 99, we'll just delete this one. And then the 100 number, will come here and print it ourselves. We know 5 can go in 100, but 3 cannot go. So the 100th number would be, let me put space here. So we print F, and then the 100 number will be buzz, right? Because so, and then there will be no space. Okay, so the last one will not have space, so we can't use this one. Okay, so let's use this like this, and let's try it. ls. Let me try that compilation again. Okay, you see the same thing. Let me gcc 9, and then just slash a.out. You just printed 1 buzz. I think there's an error. vi 9. So let me see. I equals is 1. I is less than 100. I plus plus. If I equals to 0. Okay. I think this is my error. I modulus 3. This one should not have a bracket. This one, the bracket should be here, right? And then the bracket should be here. Okay. And let's delete one here. Where's the second one? I modulus 3. This one too, we could leave it. Yeah. So let's try it like this. And then let's compile again. And let's see. Still the same thing. Let's see again. stdi.h. Okay. This guy should be outside again. Sorry guys. So this one should be outside the loop, right? Before the return. So let me put all these guys outside. Maybe that's why as well. But it has helped us fix the 1100th one. So we print F twice. Print F again. Return 0. and then this one should be boss, right? And then this one should be a new line. So let's try now. If this doesn't work, then probably I will try and solve this myself. Okay, let's use their compiler now. So it worked. The compilation works. So let me remove that a dot out. Okay, so the compilation is for 9, right? So 9 FizzBuzz. So let us run 9 FizzBuzz. So it printed it. So that was a silly mistake I made. So yeah. So if I didn't remove that last one, it won't have done. So um, I want to ignore this file, this one. So I'll put it in my .git ignore, and then come here. I'll put it here. Okay, and then I'll git add. I'll git commit. I'll say print fizz buzz and 1 and then git push. So let me check. So let me zoom in. So it has checked us, and that'll be all for now. See you. Okay guys, so in this one we have to do part 11 number 10. It says write a function that prints a triangle followed by a new line, and then this is a prototype. We have to use put char where size is the number of sides of the triangle. If size is 0 or less, the function should print a new line. So if it is higher, it should print the triangle. Obviously you should use this hash to print triangle. And if you see, this one has, the first one has 2, so we printed 1, right? So a space and then this and then 2, right? This one's printed 10, so 1. So if you notice, it counted the number of space first before it printed the first one, number of space before, like that. So more space than the stuff, and then the next one will print 1, definitely 1, right? And then 0 0. So let's get into it. So first thing I will copy is my name. Copy. And then so cd into, oh sorry, we cd into ALX low level. We cd into 004. What am I pressing? cd into 004. Let's clear and then ls. So we're here. So vi the name, and then we'll include our main.h, right? And then so the name is print triangle, and then we have the parameter of size. And the no return type, so we can end it. So we'll copy the prototype, yeah, we have void return type, this. Right. Okay. So we have this block of code. So the next thing is, if we'll put two variables into I and j. So if the size if size is greater than 0, so we have when it is 0 or less and when it is greater than 0, right? So we have a block of code to be executed. Okay, so we have a for loop. Okay, I will say for I equals 0, I is less than size, right? And then I plus plus. Okay, so this place we are saying that I is 0 as far as 0 is less than size, right? That's why we are doing this, right? Okay, then I'll come here and sorry, and then I'll have my curly braces again for this. So inside this one we're going to have another for loop. Okay, and then the for loop goes like j equals to 0 as long as j is less than size j plus plus. Okay, and then we'll have another one like this. Okay, so for this for loop. Okay, so we've said that if it is greater than, if this one is 1 for example, right, it means this thing will execute once, right? So this one will execute once, so it will print one line. Okay, so for this one to execute, we say that if j is 0 now and size is probably 1, right? So it means this one will execute 1, right? Okay, so we said this one should execute once, this one should execute once. So if this one wants to execute, it will just execute what is here, right? It will come back here. Okay, so if this one is 2 for example, okay, so it means this, if size is 2 for example, okay, 2 is greater than 0, right? Yes, so it will execute this. So it will say 0 is less than 2, right? Yes, so this one will become 0, right? 0 is less than 2, then it will execute this block of code first time 1. Abi, this block of code 0 is less than 2, right? Yes, this one will execute once, this one will execute 2 when it becomes, this one will become 1, right? This one will execute 2, this one will execute 3, yes, this one, let's continue. So let me finish up. If our j is less than size minus 1, sorry, I plus 1. So we have another if block of code, and for this if we have our parenthesis. What happened? Let me undo it. What did I use? Okay, we have our block of code, right? And then we say we should print space. Remember, we have more space first. So space is what is going to be printed. I'm coming underscore put char print space. Okay. Has the color changed? Yes. Okay. Calm down. Okay. So if j is less than size, then increase I by 1 minus I plus 1. If so we have this one to be 2, right? We have this one to be 2. So this one is 2. This one would want to execute this code, right? Let me just finish it so I'll see how I can explain. So else, right? You should print hashtag. Right? Come down. Push hashtag. Then for this if, we're gonna end it with a new line underscore put char. New line. Okay. So this one is for if size is greater than 0. So down here we're gonna have else, which is for equals to 0 or less than 0. For that one, you should just print a new line, right? I think you understand this one first. You should just understand that one and say, okay. So this one is for when it is this one is for when it is equal to 0 or less than 0, right? And then I go up. Let me reduce this one. Hey, sorry. Okay, and then this is my cursor. So this one is for this one is for if it is greater than 0, right? So if it is greater than 0, all this block of code will execute. Sorry, all this block of code, yes, I'm correct, will execute. Let me bring this guy down a bit because I can't see everything. Okay, yes. So if it is greater than 0, this block of codes will execute, and if it is, the else is for when it is equal to 0. So let's see what this block of code does. So at the end of when it is greater than 0, it will print a new line, right? So we've removed this guy, right? So let's see what this guy is do, okay, before it prints a new line. Okay, so we have two for loop and one if and one else, right? So the first for loop, let's say this one is 2, it means this guy will execute twice. So we have 2 lines, right? So this one will give us number of lines, right? Okay, so it remains this guy. Okay, yeah, okay. So this one for this one would keep executing too. So this one would print the number of what's this thing called, rows, right? So this one will print the number of rows, right? So this one is to print the number of spaces before the hash, right? So this one will help us print the number of spaces before the hash. Okay, so for j equals to 0, j is less than size j plus plus. Okay, so let me see. Yes, so this one will print it, and then if we have to, it means this one will execute uh, twice as well, right? So this one will execute one, and then we'll have this if statement, and then this one will say j is less than size, so j is less than size, right, 2, and then minus I plus 1. So this one will be depending on the I. So if this I is still 0, 0 plus 1 is 1, right? So yes, so 0 plus 1 1. So j is j, if j is 0, 0 is greater than 2, 0 is less than 2, and then 2 minus 1 1, right? So if this one minus this one, j, is this supposed to be minus? Yeah. Okay, let me see. Okay, so in order not to waste our time, let me just quickly execute it and see if it works first before I start explaining all these jargons. Okay, so we have ls. So let us bet it that 10. So this one says we are good, right? Let me clear. So let me put the prototype inside vi main.h. Bless me. Thank you. Thank you. Okay, we have this one. Okay, yes, that's clear. Okay, so the next one is we should vi we should create the main.h, right? Time main.c, main.c as a main.h. Okay, then we clear our screen. Then I can compare. Let me first compare them. I'll see what I can do with that explanation. So our compilation worked. No slash. I think 10. So I think it worked, right? So I'm coming. Let's. So I don't want to push this to number 10. Where is it? 10 main.c and 10 triangles, right? So let me copy these 10 triangles. So I'll add it to my GitHub now. Alright. Let me git add git commits. Hey shit. Git commit is triangle. Git push. Okay, so let's check our code first. So basically the math behind that one is that it should print the number of spaces, and then if it has gotten to an end like that, the end, okay, it should just print hashtag. So the next one would go up again and reload. Let me explain here. So that one is going to print the number of spaces first, and when it is close to the end of you use J to compare I, it's going to print hash. It will go back to the first loop, and then it will come back here, and then the implementation of the loop will make this thing print the second hash. You understand? So that's the math behind that stuff. So probably I'm going to crack it and see um, how I react that. Okay, let's see. The code is still running. Okay, I think because we're in the deadline again, so it's taking time. So definitely should work. If it doesn't work, then I'll make adjustment to this video, so you'll be seeing the I'll add the adjustment to it. So let's go to the next one because of time. Okay guys, so we're gonna do this task. It's been a while, I left it alone, I've been busy, so let's dive into it. So this is the 12th task, number 11, in more functions, more nested loops. Okay, so the prime factors of this number are this, right? So probably so many long number, and then this is the last prime factor. Okay, so this is the last prime factor. So write a program that finds and print the largest prime factor. That's the last one, the largest one, right, of the number of this particular number, followed by Nina. You are not allowed. You are allowed to use the standard library. Your program should be compiled using this, right? Okay. Um, so since we are using standard library, so we might not have main.h, right? So we just copy this, and then we go to our. So let me go to my cd alx low level, right, and then cd 0x04, right. Okay, so let me list it. So we'll actually try two things. I'll see if the first one works, and if it works, fine. If it doesn't work, I'll just add one more line. Okay, so sorry, let me exit this guy. Okay, vi and define. Okay, so yeah, so basically I'm going to have my um stdio.h, right, and I'm going to have my comment. I'll call this one main since we're using standard library. So this one will print the largest prime factor, okay, of a number, of the number. This thing is getting too long. Let me just reduce it. Oh no, of the number. What's the number? Let me copy it. This is the number. Copy. Right. So I think it's going to have an argument, right? Or no? Let me see. So it's not going to have an argument. So we'll just return type. So it should return 0, right? And then we can end it like that. So we'll have int, that's the return type main, and then we'll have a void. Alright, good. So I'll, because the number is large, so I'll give it a long int, right, and I'll specify a different value. Let me just say I, N, and T, and end it with a semicolon, and then put two spaces, right? So we'll set our N to be equal to this, right? So we're giving n a value, okay, already, which is this. So we want to print out the largest prime factor of this guy. Okay, so first we'll use our for loop as usual, and then we'll open parenthesis and then we can close it here. Let me go back to the loop. Did I put space here? Okay, I'm supposed to put space here. Okay, and then for, so we'll use the I. N is for number, I is for the indentation, and then we'll have I to be equal to 1 for now, and then we'll say as long as I is less than or equal to the number is what, this. Okay, oh sorry, let me just remove this one. Since the number is now n, as far as 1 is less than or equal to n, then we'll say I plus plus. Okay, okay, so the next thing is we'll say, so we are trying to loop through this guy. As far as I is less than this, what should happen? So we'll say if, oh sorry, I wanted to press tab when I pressed caps lock. So if and our if block will have this as well, right? Okay, so if our n, that is that big number, would divides I, for example, it will divide I, it will divide 1 and it will give you 0. If this happens, okay, it means that whatever value is here, whatever value is in this one would be here, right? And if it divides this big number, it means that the result is 0. It means that it is a prime number of that, it is a prime factor of that this particular n, right? So if that happens, then what should you do, right? Then you come here again and execute this code. Okay, so if it is a prime number, then we have one small if here, and then, so as I was saying, if n divides this and gives you 0, right, then you should execute this code. And I said if n is equal to I. So what I'm saying here is that, okay, once it divides, right, okay, so if that number that it divides here, if this n is, for example, 6111 is equal to 611, if our I has become 6, maybe it has increment to this point where it becomes 6 something, it means that this particular block of code should execute, and that's the way this one will enable us get that highest prime number, because if the n is equal to that number, it means that's the highest. Okay, so then we'll say n, if n equals to I, then you should print f, sorry, print f, and then this, and then because we are doing long integer, we say %ld, that's long decimal kind of, and then a new line, right? And then what are we printing? We are printing the value of I, right? We're printing the value of I. So that's when, and then when this one executes, what should happen? You should break out of the loop. Okay, so once this one happens, just break out of the loop as we've gotten our answer. But if this guy doesn't happen, let's say I is not equal to 0, then it will come down here. Okay, then this one will not be executed, so the down one would execute. So for the down one to execute, we'll then say D. We want to store a value inside this D, so we'll say our D now is equal to N divided by I. So what I'm saying here is that, so our D will now hold, if this one is not executing, right? So if N divided by I will give you 0, like the modulus I rather will give you 0, right? So it means that N should be divided. So if this one is 2, for example, you understand, so 2 divided by this guy, you understand, like if you are finding prime numbers, you would keep dividing it, right? So 2 divided by this number will give you like 3 3 0 6 something, you understand. So this D will hold the division of these two number if this thing happen. Okay, so it will hold the division. Okay, so that's what it's saying. So it should hold that division. So after that, sorry, I want to put it on the new one. So after that, then let our N become the value of D. So our N is not this large number again. We've slashed the value of N. So this thing would replace whatever N is. Okay. So N will now be a lower number, and then we'll use another number to divide it. So 3 will divide this thing and check. 4 will divide until a large number divides, and then they are equal to each other, and then it prints and break out. So there's one thing I want to add to this place, but I want to execute this code and see if it works. If it doesn't work, then I'll add that thing. Okay, so before that, then let's give our return. Okay, so return would be after the for loop. Then we have our, let me put a space, return 0, right? Okay, so this should be it. Okay, so let's try and execute it. I don't know. Copy. What did we do wrong? I'm very sure we will do something wrong. Before expected close bracket before I. Let's see. Oh, comma is supposed to be here. Yes, true. And then this one, long int. Yes, now. Okay, is I is not long int. Let me see. So let's vi back. Okay, so where's that guy that I saw? Oh, yes, this guy, this printf is supposed to be comma here. True, comma, yes. And then long int. Yes, now I is long int already. So what was going on? I is long int ld. Yes, so why are you giving us problem? Anyway, let's better the file. Betty says we are correct, so I will recompile and see. Oh, I went to open it again. Let me recompile. Yes, okay, it has compiled. I think that's just what caused the problem. So let's ls, and then we'll see the compilation name should be where is it? 100 prime. Where's 100 prime? Okay, here is it. It is here. Okay, so we'll execute it. So it didn't work. So let me just add what I wanted to add. Oh, it worked though. It worked. It wrote 50. Let me re-execute it. Maybe it took time actually. It took a lot of time and then it executes. Probably it was calculating that. So it worked. And let me just add and see. Git add. Hey, I don't want to add one particular one. As we used to do it, we add this one to our .git ignore. Copy. So vi dot git ignore. So we'll add this one to our git ignore. Then we save it. So we can git add now. Git commit m is print last prime number. Git push. Okay, so let's check it. Let's see if it works. Oh, sorry. Check code, not ask operation. So if it doesn't work, I'll just add that last line. I just want to kind of, okay, it worked. So it worked. So we are good. No need of adding the last line. So yeah, next question. Hello guys. So we'll be doing the final question on more functions, more nested loop. And on this one, we have it says we should write a function that prints an integer. You should only use picture. You cannot use long, and then you are not allowed to use array or pointers and all these things. So let's just grab the name and come back to the prototype. So let me grab the name. So in this video, I'm going to be using recursion. Recursion is when a function call itself. Okay, probably directly or indirectly. So we have cd. Let's cd into our olx. And let's see these 0004 ls. So I'll vi the name, right? Enter. Okay. So the next thing I'm going to do is start the write up. So I'm going to hold on, insert mode and include my main.h. So I'm going to include my main.h. The other file I'm going to start this guy. So I think the function name is print underscore number. Okay, and then so will print an integer, and then we have an input n, and then this one is the parameter or integer itself. So value or input. Okay, and then I think it's a void, right? So it's now returning anything. So do like this, and then the next thing we're going to do is get the prototype name. So let me go up. Okay, so let me just get this, copy it and paste it. Okay, so cutting that, and then we have our, so we are not using long, so we can use unsigned int to save some numbers. So I'll say unsigned int I. So I'll initialize I to be n. That is, this I will contain our number value n, right? So we'll go down and then so this is my first if statement, and it says if our n, which is the number that will be imputed, is less than 0, that means it is negative, right? So if it is negative, then we should first print a negative sign. Okay, so we'll print a negative sign using the ASCII character for negative, which is 45. Okay, so we should print 45, and then because we've added negative sign, then let us set our I to be equal to dash I, right? So we're setting this one to negative. So we come out, and then we can have another if statement. Okay, and this one is just if 1 divides 10, sorry, I, it's not 1. If I can be divided by 10, then this block of code should happen, which means that it is a it has more digits, it's not a single digit. Okay, so that's what this one. So if it is, then we're going to use the recursion here, where we use the function name to call itself print underscore number, and then add this, and then I'll say I divided by 10. So I'm calling the function, the function is calling itself, and that's recursion. When you get to recursion, you would be able to understand this step. Okay, and then let me see. Okay, so this one would enable it kind of print the last number. So I'll just say put char, you should print I modulus, is it? Yeah, I modulus, then that's the remainder, right? So you should print the remainder, and plus, so I'll add this one to convert it to ASCII, and then since we have no return type, so this is I think we're done. So let me just exit, and then vi into our main dot h. Okay, so I'll add that prototype here. Yes, escape wq. Do we have a main? Yes, we have a main 101 main dot c. Hey, so I think up to this guy. Copy. So we'll have vi 101 main 101 main dot c, and then we'll paste this guy. And okay, so let me just quickly add. Okay, before I add that, let me compile. Let's compile it and use this guy to compile. Copy. So we should get 98 forward to this, right? So let me first get you what I coded in 101, right? 101 print dot. So Betty said we are good, so let me clear and let's compile it, right? So compilation worked, and then we are going to execute this guy, right? So let us dash 101 print number. So it works, right? So let's clear it, and ls. So I don't want to add this 101 like I used to do. So let me add this, and one, what is it? Where is it? 101 main dots, right? I don't want to add that, so I'll add it to my git ignore dot git ignore this one, and 101 main dot c, right? So yeah, so I'm done. So let me git add, git commit, and then say print integer, and then I will git push. So let me clear my screen, and let's check for the answer if it's correct. Page down. So I've not been able to do it since I've been busy. So yeah, so let's check. So it's correct, and I think immediately you'll be scored if you are doing it after the second deadline. Let's just ask for correction. So once you're doing that, let's ask for correction, and this zero should change to 50. Hopefully, or obviously. Anyway, so let's check. Can you see it has changed? So yeah, that's it. See you.